The greenhouse effect. Hopefully you're somewhat at least familiar with the term. We're going to go into some depth with it here. So we've got a balancing act is what we say. So we've got absorption, which is when energy is added, emission, when energy is taken away, and equilibrium, when it stays pretty much the same. So when you think of absorption, I want you to think of a positive, like it gets warmer. Emission, I want you to think of it giving off heat and getting colder. And equilibrium stays the same. If an object absorbs more energy than it emits, so it's gaining more than it's losing, it's going to get warmer. If an object emits more energy than it absorbs, it's going to get colder. So if it's giving off more than it's gaining, it's going to get colder. So we've got day versus night temperatures. So during the day, we're gaining energy, whereas at night, we're losing energy because of the fact that we have the sun or don't have the sun. A black body is something that will absorb and emit all possible radiation. Examples include black surfaces, the sun, Earth. They'll all absorb and emit as much as it possibly can. Whoops. Radiative equilibrium temperature is when the rate of absorption equals the rate of emission. So in other words, when you're gaining just as much as you're losing, you end up in an equilibrium. Now, Earth is in half light and half dark. So here's an image showing the Earth. Half of it's lit up. During this point in time, it will be absorbing energy, and when that spins to be in the dark side, it will end up emitting energy. And overall, we end up having equilibrium between the two. Okay, so there are selective absorbers in the environment, and selective absorbers will only absorb and emit certain radiations. So the atmosphere is a selective absorber, and snow, which will absorb infrared radiation, but not sunlight. The greenhouse effect is the absorption of infrared radiation from the Earth by water vapor and CO2 in the atmosphere. So what it's doing is those particular molecules can absorb the heat energy and then cause the atmosphere to warm up. An atmospheric window is a wavelength range that allows energy to pass through the atmosphere and into space. So if we look at our graphs here, we've got our different gases: nitrous oxide, methane, molecular oxygen and ozone, water vapor, carbon dioxide, and this is the total atmosphere. So when we're talking about that atmospheric window, here's our atmospheric window. It's kind of an area where there's wavelengths that are being allowed to go back into the atmosphere. Here's an atmospheric window where there's wavelengths that are being allowed to pass in and out. This could also be considered an atmospheric window too, because these wavelengths are not being absorbed or emitted. Okay, so anywhere where there's a gap, that there's really no absorption or emission. Otherwise, all of these are being absorbed or emitted in the other areas of the wavelengths. So there's only certain wavelengths. You won't have to worry about knowing exactly which ones, but if you can tell me that these areas aren't being absorbed, this area there's not much being absorbed other than this peak here, you're good to go. So the shaded represents the percent or absorbed by each gas. So when we're talking the total atmosphere, we can see the atmospheric window, but when we're talking about individual ones, each of these will only absorb certain peaks of wavelengths. All right, so the greenhouse effect. Clouds can enhance the greenhouse effect, and we'll discuss the different types of clouds. Clouds can absorb the wavelengths that CO2 and water vapor do not, thus closing that atmospheric window. So even though there were those gaps that did not absorb or emit, the windows can cause those gaps to basically disappear and have absorption. The low, thick clouds will emit radiation. So these here will actually send off more radiation and prevent radiation from coming through. And that keeps the nights warmer and the days cooler. The high clouds will actually trap more heat. So these are the ones that make the greenhouse effect happen more rapidly. The warming of the greenhouse effect is essential to life on Earth. So if we did not have this warming, we wouldn't have the temperatures that we need to survive. However, we do know that the greenhouse effect is being amplified because of the additional carbon dioxide and water vapor that's being put into the atmosphere, which we'll talk about. So, greenhouse effect is extremely important. So if we did not have the greenhouse effect over here, we'd have the incoming radiation and the outgoing radiation, and they figure our temperature would be 0 degrees Fahrenheit. Well, we're used to living between like freezing, about 32. Sometimes it gets colder than that, but it'd be 0 degrees all the time. It wouldn't get much warmer than that because we wouldn't be keeping the energy. On the other hand, with the greenhouse effect, the radiation coming in, even if it's kind of going back up, it's going to bounce back because the atmosphere is going to help keep it in at the Earth's surface so that it keeps us warm. So you'll notice here with the greenhouse effect, our temperatures are closer to where they should be. 59 degrees, that's a kind of a nice fall day. It might be a little on the cool side, but it's warm enough that we can survive. If we were living in 0 degree temperature all the time, we'd have a hard time surviving. Okay, so an increase of air temperature by about 1 degree Fahrenheit over the past century, and it's increasing. So that's part of like the fact that we have the carbon dioxide and the water vapor going into the air. So we have an increase of air temperature, and there could be some bad things that come from it. As a result of this increase in temperature, we get sea level rising because all of those ice caps at the poles are not going to be able to stay intact along with the glaciers towards the north and towards the south. They're not going to stay intact because of the fact that it's getting warmer, so they can't stay cold. The primary cause for the increase in temperature is thought to be from an increase in CO2, carbon dioxide, which we figure is from burning fossil fuels and deforestation. So if we don't have the trees in the forest to use up the CO2 to make oxygen, then that CO2 is going to build up, and burning fossil fuels itself, like gases in our cars or any other type of fossil fuels, is going to cause CO2 or carbon monoxide to form. Okay, so the impact on the greenhouse effect. Water vapor itself has a 60% effect. Carbon dioxide is a 26%. Other gases is 14%. Now, CFCs are on that list too, but CFCs have been outlawed. There's articles that you can read about CFCs. CFCs are chlorofluorocarbons, and they used to be found in aerosol cans, like hairsprays. And one CFC has the effect of 10,000 carbon dioxide molecules. So that is a huge impact. So thinking about the fact that carbon dioxide causes 26% of the impact on the greenhouse effect, if CFCs were common, it'd be a lot worse. Okay, so CO2 values are increasing such that air temperature is expected to rise 1.4 to 5.8 degrees Celsius. So the problem is by increasing CO2, we're causing global warming. Well, with the temperatures getting warm, and you hear climate change too, so when you see this saying global warming, this is just mainly to point out the feedback loop. So as it warms up and as the temperatures warm up, that's going to cause water to evaporate more. Well, if water evaporates more, that means we're going to have more water vapor in the air. And guess what? If we look back at that list, water vapor has a 60% impact on the greenhouse effect. So if we're increasing the amount of water vapor in the air, that's going to warm the atmosphere. Well, more warming the atmosphere causes more evaporation, and it just becomes a very bad feedback loop where it's continuing to get worse. There are other feedback systems. That one is a positive feedback system there's other ones that we don't understand. So changes in clouds can happen simultaneously. Ocean changes that occur due to circulation, temperature, and sea ice, we don't completely understand the feedback systems that are involved there. Negative feedback is the opposite of positive. Negative feedback reverses a change. Clouds can offset some of the warming. Remember that clouds are condensed water vapor though. So that's water vapor in the air, but yet if they're formed as clouds, they can prevent that radiation from coming through, as we talked about earlier. Okay, so here's another image showing the greenhouse effect. So in some cases, the atmosphere can reflect. So some solar radiation is reflected by the Earth and its atmosphere. So you can see that this here is being reflected before it can even make it to the Earth's surface. Most radiation is absorbed by the Earth's surface and warms it. And we get more absorption on land than we do on water. Some of the infrared radiation passes through the atmosphere. Some is absorbed and re-emitted in all directions by the gas molecules. The effect of this is to warm the Earth's surface and the lower atmosphere. Infrared radiation is emitted by the Earth's surface. So here's where our heating can actually reflect up to go out of the atmosphere. But the atmosphere can also cause it to come back down. So we've got a lot of back and forths with the greenhouse effect. Okay, so the atmosphere does not absorb the radiation at wavelengths 3 to 1 micrometer that are most emitted by the sun. The Earth's surface absorbs these wavelengths. The atmosphere does not. So the Earth's warming up. The air near the surface gets warm. So here's the radiation that's skipping the atmosphere, coming down to the surface, warming the surface. And because it's warming the surface, we're going to have conduction. So the air above it is going to get warm. The air then collides with particles above it, which causes additional warming, and so more conduction. And then it initiates convection currents to create thermals. So here we're going to get a whole bunch of heating because of the surface getting warm. And it's going to rise up, and it will eventually make thermals. It's going to end up causing some of that cycling. The latent heat will be released, and we get all of that going on.